It's a bit dark. Okay, good afternoon, everybody. Welcome to FOSDEM. For those who don't know, my name is Carsten. I'm also known as Rasta. I have done a lot of open source in the last 20 years. That's basically what I have done. I started my life writing a window manager. Actually, I wrote a few things before that. And it's ended up in doing things like working on toolkits. And today, I am in fact a master engineer at Samsung Electronics in Korea. And my responsibilities pretty much revolve around Tizen, an operating system, which actually powers quite a lot of our products today. As part of working on Tizen, we are moving to a new display system in Tizen 3, and I'm going to discuss some of this journey, how it is relevant to Tizen, and how it might be relevant to things that you do, and why it's important. For those who want to know a little bit more about Wayland, this will give you some information. It's not intended to be in-depth and technical, but if you have questions later, we can talk about those. Okay, so what is Tizen? This is the operating system we work on. It is in fact a Linux distribution. It is open source. It currently does actually power 2 mobile phones that you can actually buy. The Samsung Z1, which when it came out in retail was like $90, $70 I think these days you get it for. Over 1 million of those have already been sold. There's the Z3, and that is actually going to be released in more countries as time goes on. That's a quad-core thing with a high HD screen, 1280 by 720. It's not a bad phone as such. It also powers wearables. This watch on my wrist, that runs Linux. Linux kernel, Tizen, it actually happens to run X, believe it or not. We haven't moved to Wayland yet for that. And actually has not bad battery life, surprisingly. All our TVs, all our smart TVs now run Tizen, they run Linux. All under there. You even now have fridges that run Linux. There's even cameras that run Linux and so on. They all run Tizen. So to us, our display system is very important because it covers a very wide range of products we have to produce. So the source code for Tizen, you can go there and find it, do a bit of Googling. It's not too hard. What is Enlightenment? This is in fact the thing that really got me started in the Linux and open source world. It is a window manager. It also became a compositor at some point in the last couple of years. And it is in fact the window manager and compositor for Tizen. It's what sits behind it all. We in fact also now have ported to Wayland. I would be doing this presentation on Wayland if our external screen support worked in it. It doesn't, so sorry, we're still using X. It does the compositing, those other fancy effects, etc. And it actually still runs on both X11 and Wayland today. The one process can do both. So you can just run it in different modes. In fact, run it without a display environment. It'll go into Wayland. As part of making Enlightenment, we also made this thing called EFL. I didn't come up with a name, but it seems to have stuck. They're called the Enlightenment Foundation Libraries. So instead of releasing Enlightenment for a whole bunch of years, we instead worked on all these libraries so we could build the next version of Enlightenment. Interestingly enough, those libraries ended up to be useful enough to build other things with, that Tizen today actually uses EFL as its core widget set toolkit. So all the native applications all use EFL. So these are open source. It's a combination of BSD and LGPL version 2 licenses there. So you can go and check that out in Enlightenment.org. Now, what is Wayland? Some of you, who here has not heard about Wayland? Good. Who here is currently interested? They know about Wayland, but they don't know too many details. They'd like to know more. Good, all right, excellent. That's what I was hoping. So, Wayland is new and fancy. It's intended to replace X11. A lot of people have been saying, yes, Wayland, we're going to do it this year. The problem really is that replacing X is hard. Because X has been around for such a long time, it is very, very mature. So much stuff works. So many things have been solved. Wayland has not solved those things today. We are still working on a lot of basic things just to get things up and running. It is going to be many years before Wayland is completely as functional as X is. But, even though it's going to be years, we're all working on it. And to some people, Wayland is functional enough already. So what Wayland actually is, Wayland is not the same as X. Saying something runs on Wayland is not the same as saying something runs on X. You don't have a Wayland server. You will have a window manager and compositor that speaks Wayland protocol. Wayland provides libraries to speak this protocol. But Wayland itself, unlike X, does not provide a display server at all. That is the job of every window manager, compositor, etc. to go and do that. All Wayland is agreeing on the protocol itself. Wayland comes with a sample implementation called Western, and that's the sample compositor. It wasn't intended really to be a useful day-to-day compositor for people. It was intended for debugging and working on the protocol. So there's a library on the server side, the Wayland server, for those who are writing, for the few crazy people on this planet who want to write a Wayland compositor. And there's the client side for Wayland clients. Most people will care about that, although it's mostly going to be the toolkit makers who do that. Wayland also is not just about the protocol, but the conventions. So, for example, there would be a convention that you should not mess with your front buffer, i.e. the buffer the compositor is currently displaying. Don't touch it while the compositor displays it. If you do that, you'll break some of the ideas of every frame is perfect. It's mostly built around Linux, DRM, etc. Nothing technically stops it from being ported to things like BSD and so on, but they would have to support all the things that Linux does. So, for example, DRM buffers, they definitely can support the POSIX shared memory. They would have to work on the EGL layer, etc. If they're not going to use DRM and make that portable. So other OSs, it depends. For now, we'll only talk Linux, but it can be ported. Every frame should be perfect in Wayland. A lot of the design ethos behind Wayland is in order to allow every frame to be exactly correct. You may have noticed in X11, you sometimes get tearing, things are half drawn for a frame. Wayland is trying to get rid of that. Another very important thing about Wayland is the focus on security or isolation. Who here cares about security? All right, do you use X11? Give up, don't bother. There is no security in X. It does not happen. X is a cooperative environment. Every single application that's running in X is expected to be nice and play nice. If an application does not want to be nice and play nice, game over. There is nothing it cannot do. You can remote control other applications, listen in on their input. Every password you have will belong to a malicious application. It's really easy to do. We could try and lock X down, but we would break so much functionality that it would basically become useless. Wayland has a very different design. It's designed from the idea that applications know nothing about each other. Two applications don't even know the other one exists. They cannot find the other app. And that is, in fact, a very good thing, especially for something like Tizen. We care about isolation and security. The other interesting thing about Wayland is, in X, you would have an X server, and technically it was designed so you can have a window manager and even a separate compositor. Early in the compositing days for X, there was in fact X Comp Manager, and it was actually a separate application to your window manager. They were all intended to work nicely and play together, etc. Wayland takes all of these processes and merges them into one. So you now have just one display manager, Wayland Compositor, and that is all your window manager, your compositor, and your display system, input routing, all in one. So why do we want to do Wayland? Well, it's cool. Everyone's talking about it. Everyone wants to do it. So if you want to be trendy, you have to do it too. But really, what's good about Wayland is it's free of legacy. We don't have to support all the things that X has had to support for the last 30 years. A lot has been built up over time. It has a much smaller code base than X11, which means it's easier to manage, easier to deal with, easier to modify. It's easier to get a perfect UI, and in fact, having a perfect interface with no glitches is almost one of the most important things you need when you're making a product. It's very different when you're a bunch of hackers in a room, you know, putting something together, making it work. And hey, look, it's open source, it works. Great. But when you're making a product, having every frame being entirely perfect with no glitches is one of the most important things you have to do. Supporting hardware is now going to be easier. The driver stack is simpler, there's less to do. And definitely the security. Much more secure next time. Unfortunately, the downsides, as I said before, it's far less mature than X11. So many problems need to be solved. So I mean, for example, I was running Wayland on the way here on the flight. And interestingly enough, with EFL, we tried to play some sound. We use Pulse Audio, and Pulse Audio wants to go and connect to X11. And when it tries to connect to X11, well, there is a socket sitting there waiting to possibly be connected to, and it can't connect because no one's listening. And so what happens is your application hangs because Pulse Audio wants to connect to X11. It's kind of interesting. Your audio system wants to talk to your display manager. These are some of the little things that need fixing. Pulse Audio has to stop dealing with X. It has to just assume X will not exist. Things have to change. There are going to be lots and lots of little things. And that's just like that. So now I'm going to go into how Wayland is different to X, and this will explain some of the reasons why it's better. So we're going to discuss how it might connect, like create a new window, and then actually maybe modify it. Again, when you're making products, things like an application window coming up half a second sooner is like a make or break for shipping a product. A product will not be approved for shipment if applications take too long to start up. Again, you're running like a project, you're hacking in a corner. Okay, the application takes a second, it takes a second. That's not the case when you actually have to do products. So if you can make this faster and better, it's absolutely worth it. So if you have our three processes here where your window manager and compositor are rolled into one, which is common today, you'd have your normal app and an X server down here. The application will connect to the X server. Yes, there are actually some round trips involved here. I'm not going to go into that. Then the window manager compositor will get a map request. That means the application has created a window and wants to display it. Now the window manager compositor goes and reads a whole bunch of properties, goes and does a bunch of shit. It goes back and forth all day long. It takes quite a while to do this. And then it finally says, well, let's go display this window. You display it, and finally the application will get an event saying, hey, your window has been mapped, been shown. Now the application might do things like render and etc. That actually takes quite a while, you'd be surprised. The only reason you don't notice it today is your machines are so ridiculously fast that it kind of hides it. So unfortunately, the byproduct of that is that you have three processes talk to each other, and the state of each and every one of those processes is different, because everyone's at a different point in the timeline. So you often end up with, and it doesn't look good here, unfortunately, due to the lights. Can we actually turn off the lights, at least the front ones? Is it
there's
here?
a switch box.
There you go, maybe.
Yep. Oh yes! Oh. Darkness! Woo! Excellent. No, normally my office and where I live is nice and dark, so I like everything dark. Keeps my eyes sane. So you often end up with things like garbage here on the side of a window, where if you look at the title bar, the close button is over there. That's where the window manager has resized the window, but the content has yet to catch up. Even in composited environments, this happens. It is technically possible to fix it, but it involves a lot of round trips to and from the X server, then back from the X server to the client, back and forth, etc., etc. Wayland does effectively fix this. It removes that bug. And that's a result of the complexity of three processes all bouncing back and forth. So how would rendering actually happen? And this is one of the big differences between Wayland and X. In X, an application will go and say, render this, draw this rectangle, paste this here, whatever it is. Then they'll paste something else, draw something. While they're doing that, the X server will send over events to the compositor saying, this got damaged, this got updated, this region changed, this region changed. So you'll get a whole bunch of those, and finally at some point the compositor will decide, oh, I better update the screen. So the compositor will go and decide to actually do something. It means that it takes quite a while for rendering to hit the screen, and the compositor could update in the middle of you rendering a bunch of things. So you've half rendered something, and then the compositor displays. So you end up with partial content. You don't see it all, and maybe the next frame, the rest of the damages will come through, and then it gets fixed. And for one frame, you see something a little bit wrong. Again, you're making a product that's unacceptable. People don't like that. It's really bad. So you end up with things like this. You'll have like a tearing line here. That's one of the very common ones. Something is busy uploading pixels, and it's copying them to the pixmap, or the X server is actually doing the copy. But the compositor starts rendering at some point in the future while something is still busy copying to that buffer. So you'll often end up with these tearing if you're unlucky. You also got this before in X11 without compositing, because everyone would render to the same script. So if you're rendering client-side X11, what invariably happens is the clients will just render locally using CPU or maybe GL. And then you have to copy all of this up to the screen. No matter what, that's a copy. If you're doing something like updating just a normal 1080p, an HD screen, that's like 500 megabytes a second. If you have an embedded device, that's like a vast majority of your memory bandwidth for the low-end devices. For higher-end devices, it's still a really big chunk. You don't have that luxury. And it's 2 gigasecond for UHD. So that's a lot of data. The amount of memory bandwidth needed for graphics generally dwarfs the amount of memory bandwidth you need for networking. So if you can cut down any of these copies, you end up with really big performance improvements. You can almost double your frame rate if you get rid of these copies. So no matter what in X11, we're invariably forced to do a copy somewhere if you do display client side. If you render server side, it requires your compositor to have a complete rendering engine to do all the rendering commands that a client would need. This requires then that your server have that rendering engine, and it must be pixel perfect. It must produce the exact same pixel results in every single X server on every single driver everywhere for the same commands. Luckily, it's already been implemented once in the X server, and it's there, and it's forced to do this. One of the reasons X actually did this long ago was because we didn't have shared libraries. And if you had to have a whole bunch of rendering code, every app would need a copy of that in memory. If you had it in the X server, then everyone could share that same piece of code, because you couldn't use shared libraries at the time. But today, the reasons would be that it could possibly accelerate it, etc. But Wayland doesn't do this. Let's now talk about input events. In X11, input basically goes straight to the client. The window manager has no choice in that input. They can do simple things like set what the focus is. This window is now focused, therefore keyboard input will go there. But otherwise, the window manager can't do anything about input. The X server just sends it directly there. You click in a window, the X server is sending input directly to that application that owns the window. The window manager doesn't have a choice. So one of the downsides of this is that you basically can't scale and rotate applications on the compositor side. Your applications have to be at the same XY location, at the same size that they actually physically are in the screen geometry. You can't go scale it up for accessibility reasons. You can't go rotate it 90 degrees. You can't do that. Clients could do it internally, but the compositor can't do anything. And this is kind of really bad if we want to do interesting products with it. So all you do is set focus, and that's about all you really do. Even worse in X is that not only can the window manager just set focus, any application can go and set focus itself. It can go and steal input whenever it wants. And these kind of things actually lead to race conditions and fighting often, because with X you can actually have different focus modes, where sometimes the window manager sets focus, sometimes clients set focus, and you request a client to set the focus. So everyone's going to be fighting there. It's not really brilliant. And of course, as I said before, with security, all clients in X can basically listen to all input. Disabling that is going to break things. You really can't do it. And in addition, they can steal input. So for example, one of the famous bugs that was filed with GNOME is, I think it was GNOME, is, hey, I've got a menu up. My screen lock doesn't work. The screen lock doesn't work because it can't grab the keyboard because the application of the menu that's popped up has already grabbed the keyboard. So the next grab fails because one application can go and steal all input and say it's mine. These are bugs which are really hard to fix in X. In fact, there is actually kind of a workaround for that. There's an extension, one of the X fixes that allows you to break an existing grab. But that's a workaround. The design problem is still there. So, and technically speaking, someone could use that extension to break someone else's grab who has a password entry that's trying to do something with it. So these things happen in X. That's really not great. So why does Tizen matter? Why do we want these things for products? Apps can be sandboxed. Reality is that for us, applications are untrusted. They're not open source. You can't inspect them. You can't audit them. You cannot trust the people who wrote them. Reality is Trojans will happen. Applications will want to go and steal your contacts and your emails and send them to somebody to monetize you as a person. We do not want this to happen. We want to take an application and put it in a box and say, you can't do anything bad. You have very limited access and only to things you've explicitly requested and that the user said okay to. In X, that's really hard because an application could just go and remote control another one and get data out effectively. But we can't trust apps. We, on the process side, we actually use something called SMAC, and SMAC allows you to effectively container applications into what is really a sub-user ID. So you have a normal user, and then SMAC effectively gives you a label, which within that user is pretty much now a child user underneath that. And using that, we can contain the processes. But in X, you can escape your process by going to the X server and then basically faking input on something else and messing around. And you can go get other applications to do things. Even though we've tried to contain the process, there's a big gaping hole in X. So yeah, we can't trust applications. It's just not viable. They're not going to be open source, and they're not distributed like normal Linux distribution. So that's why we want it. We want it because we can get rid of a lot of the copies that we have in X11. Wayland is very much designed around the idea of zero copy. All you do is you fill a buffer and then someone uses the buffer later. We target embedded devices. We have TVs, we have watches. These things are not extremely powerful. Admittedly, this watch is far more powerful than my first PC. It's amazingly powerful, but it has a 3D accelerator. First PC didn't have. It has at least at least 5 times as much memory. A ridiculously large amount. But even so, we do have to cut down these copies. So limiting them gets us much more performance, smoother interactivity. We want perfect pixels. We don't want to see partial updates. It's meant to have commercial quality. Reality is the competition. You look at iOS, you look at Android, look at OS X, you don't see tearing. You don't see partial updates. We cannot feasibly ship products that don't at least match the quality of the competition. So we have to do this. The awesome bit is everything we have to do for products is really great for the open source community because all the work we put into all this code, which is all open source, you can recycle for yourselves and have a really nice experience. So that's a real bonus. But if we care about the things that most, generally speaking, community isn't interested in. Community is interested in other things. So together, we actually solve different parts of the problem. So we massively remove the number of round trips. It's at the point where on devices, we've seen like 400 milliseconds difference in startup time. That means process executes, window turns up on screen. And we've seen that drop by 400 milliseconds. That was approximately like a third of the entire startup time disappeared because we're using Wayland. So it's much better in this regard. It's giving us much better results. Memory footprints are going down as well. We save anywhere from about 1 to 11 megabytes per process. The compositor itself, we're seeing somewhere in the region of 40 to 50 megabytes saved. The numbers I have are about 48 meg. Admittedly, this will change from driver to driver, GPU to GPU to resolution, etc. But that's actually a reasonably good saving. So, for example, our low-end phone, the Z1, it has 768 meg of RAM. A chunk of that memory gets pre-allocated to like media subsystems, etc. So 48 meg of RAM is give or take somewhere around 10% of your actual available memory. And if you can save that, that's absolutely worth it. That can be used for processors or something much more fun. But we save all this memory and we're not really giving up a lot. We actually have pretty much the same functionality. And if anyone wants to look, I can run Wayland on my laptop here later. You can go see it. It pretty much works exactly like the X11 one does. What's really good about Wayland, and also part of the zero copy, is it really supports hardware layers. Most PC hardware, desktop hardware, doesn't really do a lot of layers. It does exist, there is support, but it is not really centered around unit, this buffer, scan it out here on screen. This hardware unit, this buffer, this location on screen, scan it out. Then a lot of these hardware scanouts can do scaling and rotation as well. So it's already used for video, but they often can alpha blend and other things as well. So if you have a relatively simple UI, like let's think desktop, you have one window, like a taskbar at the bottom, a desktop background, you can actually take that window, drag it around on screen, resize it, and the compositor doesn't have to render a single thing. What's happening is all it's doing is assigning your desktop background, your taskbar, and that application to 3 different hardware layers, and just moving the hardware layer, which means it's really just a few instructions. The things that make this possible are things like KMS, which allow atomic mode switching these days. Well, we're really close to that. So you can basically take a layer and reconfigure it, point it to a new buffer, without there being any glitch. So between 2 frames, you just say, next frame, point to this, and it's over here instead. That's what allows us to do it, and that's really good. Because now all input goes to the compositor, we can rotate everything we want on the compositor side, if we want to do this. The reality is phones, TVs, tablets, they require rotation. Yes, even TVs. We actually sell our TVs as signage, and you just rotate them sideways. So we need rotation, we actually have to do that. Today, we're kind of faking it and messing with it on the client side. So the applications do their own rotation of their own content. It requires your actual toolkit have that support. EFL does have that support, and so that's why we use it. But with Wayland, we can simplify this and put it in the compositor. A really cool use case would actually be like, remember the Microsoft Surface? That you might have multiple different applications or windows at different rotations on screen, and each one's facing a different user, because they're all crowded around a table. Without being able to actually do this nice in the compositor side, it's going to be hard to make really nice products like that in the future. Sorry. There we go, okay. So how does Wayland work instead? So generally with Wayland, you'll have the application connect to the compositor. There is a round trip here. And it'll just go create a surface. Then it'll say, here's a buffer to display, because the client knows what size it wants. It'll send that buffer, and that buffer will be rendered with those pixels. And when it's done, it'll say, I'm ending my transaction, and any changes that's made up to that point then will be put into effect by the compositor. So until then, those changes are kind of held effectively in a queue and won't be displayed, or shouldn't be. When input goes back, the compositor just sends input directly to the client. And when a new frame is needed, for example, the screen refreshes, like with VSync, every time the screen rescans, the compositor will say, hey, give me a frame, Cool bit about this is applications now can actually synchronize their rendering to screen refresh. So they can, quote, provide a perfect number of frames. And then they will just send another buffer with a new update, and they'll end their transaction there. The actual rendering is done on the client side of Wayland. And X11, X done on the server side. So traditionally in X, you have a single frame buffer, only one blob of memory, and everyone shares this without the compositing. There is some off-screen stuff with pix maps. We use a lot more of that today. But traditionally, that was just an added bonus. Everyone renders to the same frame buffer. So what will happen is applications will render, and they will effectively rendering to the same blob of memory at the same time. This was generally to save memory and make things more efficient back in the day. We don't really need that anymore. So when an application renders, it'll have its content clipped to just the region which is visible on screen. Stuff that's not visible will not be rendered. You can actually bypass this in X and say, screw you, I'm going to render across the screen and blast on everyone, and I don't care. Not many people do that. No, not many people know this feature exists, but it does. Any client can do it. But mostly clients, all they can do is render to local memory and upload. And that generally means a copy. They can use the GPU to render to a buffer and use DRM to swap. Believe it or not, the swap often is implemented as a copy. It's not actually done as a swap. Often because that's the only way you can do it. There is no actual ability to swap. So when they're actually rendering on screen, if you have these bunch of windows, if we wanted to render to that window, we would have that region there. It's just everything gets flattened out. You would have that. You want to draw that triangle, it would clip it just to those pink regions there. It would just draw those pink regions on screen, and you'd end up with that result. That's how traditional X works. If the content is not visible, it does not exist. There is nothing there. There's no content underneath another window. That's why X couldn't do semi-transparent windows for a very long time. In fact, who here has seen like the transparent terminals back in the early 2000s, late 90s? Do you know how that was done?
Grab the behind.
Well, it didn't grab it. What happened is the person who set the window background set a property on the X server root window, and said this pixmap ID is the background. And so every application would go find the pixmap, and it wasn't their pixmap, it was someone else's pixmap. And in X you can actually do evil things like set shutdown mode to say, I'm going to create resources, and don't delete the resources when my client exits, leave them in the X server so they actually leak away. So you can actually do that, and that's what you did. And so this pixmap would stay around, and you could find the ID, and then any client could use it, and they all used it as a source to copy into their window and pretend you were transparent. That's why when you put two terminals on top of each other, you didn't see the other one below. They were just copying what the background was into it. That's why if you had icons on your desktop, you couldn't see them under the terminal. So what the file managers actually did is they'd open a window that fills the screen, they'd copy that same pixmap into theirs, and then draw their icons on top. That's actually how it all works. So no, you didn't have transparency. You had a very, very, very evil hack. It was horrible. So then at a later stage came the idea of compositing in X, which would force rendering not to go to that one frame buffer, but for every window to be redirected to a pixmap that represents the content of that window. The X server actually does the allocation of that pixmap, so whenever that window resizes, the X server will allocate another pixmap, and the compositor has to go get that pixmap, find what the ID is. If the window is covered by something else, the content now actually exists because it's being forced to be rendered away from that one big frame buffer and off to another pixmap. So you basically would have those end surfaces off in off-screen memory, and if you're rendering to that, you'd render to your triangle there, and then the compositor would come and draw the background, draw the window on top, draw another one on top, draw another one on top, draw another one on top, and you'd have the same result. That's how compositors actually fundamentally work. They're taking everything and drawing it a second time on screen. Of course, you try and be a little bit smart about it, but that's the simple version. So Wayland display is much more the X11 compositing model. It's every window, quote, quote, has a buffer or a pixmap. So everything exists. You can't have the case where if something is partially obscured, the stuff that is being obscured isn't rendered. Partly because no other Wayland client or application knows the other application exists. They can't get their geometry, they don't know something is on top or partly on top. They're never told and they're not meant to know. So applications render to their own off-screen buffer memory. They have client side. The compositor is not involved in any rendering. Technically, Wayland compositors cannot draw a single thing, even though they actually have to. They do not have the same rendering client side does. And when they're done filling their buffer with everything perfect, they send the buffer over to the compositor. So when you have a setup like this, an application will have the compositor request a frame to the client, say, hey, screen refresh, we need something. The compositor then will go and take a buffer from a pool of buffers it has floating around. Technically speaking, if you're using GL or EGL, EGL will take care of this for you under the hood. But that's actually what happens. So you'll get the buffer and draw it locally. Then you'll send the buffer over. Remember, sending is not copying the data byte for byte. Sending is saying, here's a handle for that buffer, go display it. And the compositor side already has that buffer. The compositor then will display that buffer in some way. It may use the GPU to render it may use the CPU, it may go and say, hey, this hardware scan out this buffer, if it can. And again, for the next frame, you'll draw locally, send the buffer over. Previous buffer 1 is still being displayed, so this buffer is just waiting and pending. Then now buffer 2 will be displayed, buffer 1 is released, put back in the pool, and repeat, repeat, repeat. That's really how display happens in Wayland. It's really simple, it's a beautifully simple concept, and it's one of the things that makes Wayland very efficient. So this means that display rate will be linked to your screen refresh rate, which is really good. It makes for much smoother animations. We basically can do everything zero copy. Catch, maybe the compositor, if you've got shared memory buffers, have to actually copy the shared memory buffer to a texture. That's a compositor side detail. Buffers, you can have either POSIX shared memory for buffers, or you could use DRM buffers, so you can actually do both. You do not have to use OpenGL to use Wayland. You do not. It's absolutely not required. And basically, you just memory map the buffer, fill it with pixels with a CPU, or any other way you like, and you send it over to the compositor. GPU accessible memory is what your EGL layer will deal with. In order for hardware scan out to actually work, you will need to use DRM buffers, i.e. GPU accessible memory. There are a whole bunch of flags on this memory. Just because the GPU can access it doesn't mean necessarily the scan out can access it. There is some older hardware, for example, where only the first 16 megabytes of memory is what the hardware scan out can read. Anything else is only readable, let's say, by the GPU through the NMU. But hardware scan out has to be in the first fixed physical 16 megabytes. So if you want to create these buffers and render for them, you have to explicitly request a buffer that is able to be scanned out. But the result is smooth rendering with no tearing, as long as you're able to render fast enough. So Wayland is better than X11. Okay, didn't get the message. Wayland is good for Tizen because Tizen needs to create products. We've been busy doing this transition. So how did we do this? Yeah. So first, we had two major things to do. We had to do client-side toolkit. EFL had to be ported. This is actually relatively simpler. We also had to work on the compositor and window manager, which has come later, which is why it's still a bit unstable and has issues. The client-side is pretty good. So we started with the client-side and we used Western to test against. We ported the window layer first, so you can display a window at all. Then the rendering, and then all the input. It was not that difficult, but it's mostly there working, and this is often the best way to do it. We also then made EGL and GLS work. We first did software, because software is more reliable, i.e. you don't need a driver that works, you don't need a driver layer that works. You just spin up the CPU and do what you need to do, allocate your buffers and send them. Then we did the compositor side. We first needed a display engine that instead of sitting on X11 or as a client to Wayland Compositor would actually talk directly to hardware. I use KMS DRM, so it could take over the frame buffer. We had to, we started of course with software, and we have all the EGL and GL stuff working too. That was next. We started using libinput, which came around a bit later in the Wayland lifecycle. And this is basically an abstraction over a lot of the kernel interfaces, the devices, to handle all the different kinds of input devices like touchpads, mice, actual touch panels, etc., keyboards and so on. So we use this library to save ourselves time and effort. In fact, pretty much everyone is now using this library to deal with it. So ultimately, the Wayland world will probably move to a whole bunch of libraries that encapsulate handling of all these resources. So I said libdrm already handles some extent of this on the display side, and libinput on the input side. We also had to make compositing non-optional. So when compositing came into Enlightenment, it started as an optional module that used all the X11 infrastructure, but that had to actually change because in Wayland we can't make it optional at all. It has to actually all the time. We needed to now use the new engines we had instead of the X11 ones. We had to use new ones. We had to isolate a whole bunch of X11 code. Being it's an X11 window manager, it had quite a lot of X11 code floating around. Interestingly enough, it wasn't actually that hard. We'd already isolated a lot of it. It just we had to isolate it even more. So that's what we did. The compositor side. So now Enlightenment these days is both a Wayland and X11 compositor as a result. The Wayland side, it can actually even run in a window, but the preferred mode is direct to frame buffer, KMS DRM. You can use EFL apps. They work in Enlightenment. They actually will work in Western as well. They should work in GNOME and KDE as well. They're Wayland compositors. If there are issues, please come and talk to us. But they can run in both. So you can switch at runtime, just whichever one works. And the result now is Tizen can move to Wayland. We are well on that path. We've got a lot done. There's still niggles left. We're working on that. Since almost all clients in Tizen use EFL to display, they basically got ported pretty much for free. We did have to do a lot of yelling at people who bypassed the compatibility layers and gone straight to the X ones and decided to say, ooh, let me just change X properties. And we go, no, you don't change it. But it's easy. No. And then every time you just tell them, but Wayland. And then they stare at you blankly going, what? So we have to train people not to use the X APIs. But a lot of that now is being done. So we're almost there, and it's actually working pretty well. End of presentation. Anyone got questions? Small furry animals, flames. All right. Yes, I will. Okay. I'll do first. Firefox Mac.
So I have a question about Wayland. In Firefox, actually in Servo, we have experimental compositor that actually manages to move much of the compositing to the GPU itself, rather than doing it on the data processing mode, rather than doing it on the CPU. Would that be possible for the future of Wayland?
Okay, so his question was, in Firefox they have now a new compositor which moves a lot of, a new experimental compositor that moves a lot of the rendering to the GPU rather than from where?
The compositing itself.
Yeah.
I mean,
where was it before?
Well, CPU in memory.
Anyway, moves it from the CPU in memory to GPU. Would that be possible with Wayland? And the answer is yes, that is exactly what we do. It is actually what we do. So I didn't cover this in detail. Enlightenment's display system is in fact EVIS, a canvas. It's the same canvas that client-side uses. It's the same library, same layers, and everything's just an object. And so it just tracks every object, its properties and so on. It could be an image, which is either pointing to a file or just a buffer of pixels. It could be rectangles, text, etc., etc. Entire widgets. And the compositor goes and draws this together. How it draws this together is just a rendering engine. And it can basically either say, hey, let the GPU do it, GL, and GL does it all. Or the CPU can do it. It is hidden from the layer. That's all below that layer. You don't know and you don't care. We just implement a new engine, then we say use that engine, and we're done. Now that engine does all the work. And with Wayland, yes, it's designed to do exactly this. Any compositor can do it. The way we did it is we already have that abstraction layer for clients. Any client can use GL to render everything. Your text is rendered using textures and triangles and so on. Your buttons, everything is rendered that way, and you can render with the GPU. We do the same on the compositor. It's identical. The awesome bit is the compositor actually has a full UI with widgets and toolkits and everything for free because it comes from the library. And it gets rendered with GPU. So yes, you absolutely can do that. Yeah, cool. Okay, your beard.
So first disclaimer, I'm not working with graphics, and if I heard 35 rendering in pixels, I'm with black. I do happen to know that this phone uses Wayland and Qt, and the technique is about 2 or 3 years old.
Mm-hmm.
So how did they make it 2 or 3 years ago, and you say you made it now? You make it
what
now.
they do is
So
they have it in.
different.
Okay, so the question is, several years ago, 2-3 years ago, they're using Qt and Wayland on that phone. Why are we doing this now? How are we doing this now? And how's it different to them? So first of all, their compositor is far, far, far simpler. It has very fewer features. Our compositor is actually fully capable of a full desktop environment. Theirs will not be. It was a very simple, we just have full screen windows and then we do an animation in between. Effectively, I'm simplifying it. But it was basically far simpler, and that's why they could do it. We actually have the full desktop working as well. So that's been a lot more work. A lot more. Yeah. Okay, I'm going to go back. Red.
I've worked on a commercial digital signage product,
Yep.
and we had to solve that input portrait problem that you discussed. God knows, if only we'd had Wayland, we'd have saved probably a year of engineering building that product. Solving tearing, solving input. Wayland is a godsend. I only wish it had been there 5 years ago.
Trust me, we actually solved all those problems in X11.
So did we. God knows.
It took
how
us
many
years.
bug fixes we have upstream?
Yeah, we actually have tear-free rendering in X11. It took us a huge amount of work. I spent a lot of time with our graphics guys saying, you can get zero copy in X11 if you do these little tricks here, 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 and here, and here, and here, and here, and here. They eventually did it.
You end up with tricks and innovation all over the place, but you wish the hell you didn't have to do it.
I know, and Wayland is the clean version of that. So, okay, sorry. He said,
So thank you, it's a brilliant thing to come.
Sorry, the question was, he said that they actually tried to solve the same problems about rotation, tearing, all the perfect pixel things on a signage product, and
We did
it's
it.
the same problem.
It was probably 1 to 2 years of engineering to get it perfect.
Yep. Wayland,
Colossal expense.
Yep. Wayland cleans this up a lot. So yes, green.
Yes.
Blue-green.
I have a desktop application. We use an X11 module to test it, to send it input and try to automatically test graphical application. Basically, we send it events and we try to figure out if the right thing is going to appear on the screen based on that. How do you do that with Wayland if you can't interfere with another application?
You can't. Okay, so basically they're doing UI testing.
Yes.
They're doing UI testing where they're having one application basically send fake input to another, then watch the screen to see what happens if it's there and it works properly. And how do you do this in Wayland?
Yeah.
The answer is you basically don't. You will need special compositor extensions that allow you to do this. You will need help from the compositor. Compositors in general will say, hell no, we're not doing that, that's a security hole. We're not touching it with a barge pole. What you invariably will have to do is find another way. So I'll give an example. With EFL, we actually can do this, but we don't need another process to do it. We can do it inside the library toolkit. It's something called exactness, and allows you to fake events and capture input, and it does it inside the client itself. That would be one way of doing it, do inside the toolkit. I'm terribly sorry, we're out of time. You can come ask questions outside later. Thank you very much. If anyone doesn't know, I have videos.